What were you guys thinking? Can I ask?
What was that?
What were you guys
So-
thinking?
There's a lot
These are all mine, and I'm not sure
animals
which of
that
them
need moisture.
you had. But I don't
What I
know
would
which
do
it is.
is
Take them away.
maybe
Anyways,
spray bottle. Get a spray bottle.
I have the
Use your
idea of
finger
like the
sensor.
feeder that
Be
would be
like, okay,
outside and
feels
with
right.
like
Like that right there.
a butter resistor, and when the cat like cut its
Um,
paw or its head or its nose
you'll
or
notice in the
tail,
little
whatever,
knife
in front of it, the butter resistor is really smooth, which would
They,
send a
what we do
signal
with
to
some other types of animals, there's
with
one
the
thing that's
Bluetooth
moist.
sensor, which would then send
They're climbing
the
around.
signal to like Maxwell and like Anderson. For example, if we were in close
Basically,
proximity.
It's really
Just
hard
let
to
us know
plaster.
about,
I have tons of it at the bar. And you basically turn it into a rock. You can squirt it with water, it holds the water in it, and like
Oh, my
slowly
friend has-
releases the moisture.
Really?
So if you had like,
And then he was saying, you got the email
and
that we
then
intentionally like
you want me to
laser,
put
and we
like
have
two
to put into like a
dimensional
secret food
and
storage, and like.
they have to be on the dirt
all, like,
and
packed
stuff
in.
too, but if there was like a separate like living and then like, you know, running around zone, but you
Because
still
if
want
we have a
moist,
cat that we
you
can
use the
interact
fuel
with,
cell.
yeah. Andy.
Yes.
Anna has a cat friend.
No, I thought it was a cat.
Okay. Your friend's cool?
Cool. She said I can use a cat.
Okay.
But do you, I mean, we can still go back to the drawing board. Well, you were thinking of the laser, which would point to a.
Doesn't have to be a laser.
Well, because like, how is that being input and then output? Like, how would we need to program an Arduino with the laser? Because we could simply just point the laser.
But, so what I was saying was, you have something mounted on your cat, that, let's say, and then like a laser on a like servo, or maybe even two servos, like Danielle had.
Okay.
So it can like look around the room.
Okay.
And then you have some sort of sensor on the cat that maybe when the cat is walking around, maybe it like points the laser at some sort of thing in the environment or something. That could be a little more complex, but I was just tossing out ideas.
Yeah, the reason why I think it would be hard is because we would have to find a way to program it so like the laser follows that thing. Like if the cat turns left, the laser will have to
Oh, exactly. Yeah.
revolve too.
Totally. Yeah. You could do, it doesn't have to be that. And it doesn't have to necessarily follow something in the environment. I was just trying to propose, like, that was a really high-end concept of something you could put on a cat.
Yeah, I like that idea though. That's a good idea. It's kind of like your photo resistor when I like using the photo resistor.
I wasn't thinking of the light anymore, like you could do the same thing, just reverse. Once it starts being light.
Oh, that's pretty.
Can I be part of this conversation?
Totally, of course.
Oh, well, I guess you guys all have these themes of like long distance, like the Bluetooth thing, and like, what if the cat is like over there and you text something over there? So what if you kind of combine those and it's like, the cat is somewhere else, so maybe like a laser pointer that's on the top, like if you have a 2-story building, like a laser that's on the second floor and it's like pointing downwards, like turns on and like moves around or something like that. So it's like a lot of this like long distance stuff. I thought it was cool that you guys were doing like weird long distance.
Yeah, that's cool. Maybe just want to go back. Like we got me other ideas, so not being cat, maybe. Go get a bunny. We can get a bunny as long as it's yours. I already tried that last year, and
They
they
chew through everything.
and they just poop like nobody's business,
Well, you could feed them things, they could make art with their food. I'll present on that later.
like flies.
Exactly.
Hello.
Hey Larry! Your extra storyboard's laying up there.
Yes, there it is.
The next part of our project is due next week.
Let me look at my calendar.
Pretty sure. Where did you say it was?
Right there.
Thank you.
the next part of your assignment, so everyone should be aware, October seems to have a bonus weekend. So everybody go, relax. Because there's this secret bonus week that nobody seems to know about. Next week is not the last week of October, which is crazy. You have 2 weeks until Halloween. 2 weeks. And Halloween is when we're going to do our next set of presentations.
Okay, so we have like 2 weeks till our next part is due.
Well, that's
Yep.
good, so we can have time.
So this weekend, we can like do that.
You need to nail down what your animal does.
John,
That should
so
be,
heavy.
It's not that big. Bandit.
Yeah, she's thick, but
Ah.
yeah.
But
But I'm not
She's thick, but it's totally food.
I like a work.
Claire, okay.
Taking advantage
Or-
of her, yeah, no.
Wow, worms are great.
They're night crawlers.
This is John Claude.
Are there 2?
There are a lot.
There are a lot?
Where did you get them? We pet smart.
This cat would be cute.
Ew.
Yeah,
The other either are dead or not. Wow, no,
Hey Larry, can you hit the lights while you're back there?
yes. Hit them.
Howdy, howdy, class. You guys have a good break?
Yeah.
Cool. So today we're going to do all kinds of presentations and catching up, and it's going to be our midterm. We're gonna have a midterm in the class. Okay. So before that though, Eric came in earlier for my office hours, and he got his project super blasted with Andy rays. It was awesome. And that brought up some cool things to show you guys. So one thing is thinking about ways that your animals can interact with the everyday world. And so here's one of the ways that this artist uses. Wow. Is that big enough? It's not full screen.
It is fun. What is that? Maggots? In this home?
Yep.
He ordered them.
Fly larvae. Yeah, it looks like he just bought them.
In this home, just out in the open?
I think he does it in his shed. Because I remember reading an interview with him where he left his art and then his whole shed filled up with flies. So that was some gouache. You guys know what gouache is?
Yeah.
It's a type of watercolor paint that's more opaque than normal. It's kind of like, like more acrylics. Like watercolor is usually very transparent and stuff. Gouache stays a lot more opaque, but it's still like safe for animals to ingest or you to ingest. It's biodegradable. Isn't that great? Look how much life he just has. So that little substrate is soaked in like a red gouache. There's a canvas the flies go onto. The flies do this thing where they like to kind of eat something, go somewhere, kind of like, oh, I want my lunch to go. And then they start puking it up, unpuking it, puking it up, unpuking it. And so he just has these canvases hanging around that you can see it's got little spit. These are called blowflies. They spit up these little bubbles of goop that they eat, let it kind of digest the outside, let it digest inside, back and forth. They're such a cute little creature.
I would puke.
I wonder how
Well, the thing is, I'm less worried about catching them, more about them getting outside. I can barely handle one fly.
What do you do with that when you're done?
So that's where I'm concerned. Like, can you just set it on fire and then?
Yeah, can we just like, that's what they made?
Yeah, so here's some of their weird paintings.
And then we're all really impressed.
I'm impressed that you would think that to me, but I can appreciate that.
So, some of the things about it though is,
Wow.
I would qualify this as even below a stupid pet trick. It's kind of an interesting way to visualize behavior of the animals, but it's still very one way. The flies are doing one thing. One thing that could be really interesting is if this guy went a little bit further and did something where he actually, I'm going to show you one of his paintings real quick. I have to go onto Facebook to find it exactly. This actually looks pretty cool. So, you know, he has these flies and they just kind of fly all over. It's like, okay, great, I got flies to spit. We make these kind of Mark Rothko-like paintings, very fuzzy impressions. One thing that'd be cool is if he did something where he actually tried to do something back to the flies to maybe control where they went, or even influence it. Like, even if he had like a strip of like a heated coil that was behind the canvas, then you could see where the flies, maybe they don't like the heat, maybe they really like the heat, but you would get a visualization of their response to this very simple stimuli. And you could even do something where you track where the flies are going, and then you actually change whatever influence you're having on them. Maybe the moisture level of the canvas, maybe buzzing on the canvas, you could have like vibration motors. Different ways that you could react back into the real world could make this, in my opinion, a much more interesting piece, especially in the kind of realm that we're looking at. Cool. So while we're talking about that, there's earlier I was talking with Eric about how to ways of trying to sense what his worms are doing. And we were discussing ways that you could store the worms and have them live. So either like a three-dimensional box, maybe a two-dimensional plane, or even like a one-dimensional tube of dirt. And we were discussing ways that we might be able to sense these worms. And so keep in mind that not only is your world manipulable, you can, you know, make like a base thing that moves around, carve out wood to build a contraption or whatever. You can do things to make sensing your animals easier. You remember the ant painting video where people painted little codes on ants? They do that because ants all look the same and they're very hard to track. But if you put brightly colored dots on the ants, then maybe you can figure out where they are visually much easier and get unique identities. Worms are a bit trickier. You can't paint them that well because they have that smooth, squishy skin that freaks out Alex. I don't think you can paint. Huh? I think paint pens are going to be kind of toxic for them, but they're very porous and they look a lot like the stuff that those flies were just eating. So maybe you can't paint them from the outside, but maybe you could have them eat paint, eat this water-soluble paint, and their whole bodies might change color. Or maybe even just their poop would change color.
So, but is that paint like you can eat that paint?
Yeah. You can eat watercolors.
So like
It
maybe
tastes kind of sweet.
For breakfast.
the water, like when we add water to this, what if we put food coloring or would that not work?
Food coloring is safe too. Try it all out. So you know when I'm always saying like, you guys need to play with your animals, you know, live with them, experience them. These are like the kind of things to like, you know, just be doing. Be like, I'm gonna put 10 worms in a box of dirt that I dump a bunch of food coloring in. I'm gonna put 10 worms in a box of dirt that I dump a bunch of watercolor powder in with. And then just, you know, compare the worms afterwards, see what happens. Those are the kind of things that, and maybe you'll find out while you're doing this that kills both the worms. But while you were doing all of this, you think of some other way of doing something. And so we were actually discussing maybe not being able to visually sense the worms, but is there a way that we could help ourselves sense the worms in other ways? So like, what if the worms were more metallic? What if they were more magnetic? And so there's things you can get very fine iron powder. Make sure it's magnetic iron powder, not rusty iron powder. But you can actually mix it with paint and do things like make magnetic ants.
Productive member of society.
So
what
here's-
happens?
Right here.
I'm having my attack.
So here's an ant.
Hey
I
everybody,
put some very fine
I'm
paint on.
red.
And
I'm still productive member of society.
I'm competing
but
with.
what happens?
So right there, I put a magnet underneath it, and now
I'm
I'm sliding the
now.
ant around.
The magnet is making me a Hulk. My behavior is different, even though I'm physically the same. What
How did
will
the
the other
internet
ants
react to
do
you?
to me?
The
Gonna get angry.
ants about the normal response. People were like, "He's a jerk. He hates the ants," and then other people were just like, "This guy's
You're
a."
gonna bite my head like last time? Yeah, you're gonna start biting my head.
You just look up magnetic ants to find me.
He's pulling on him.
I
Yeah.
don't know why I had these seizures.
So this was what was kind of
happening,
interesting.
but I had the mysterious
This ant,
red
while it's
meat
walking
surgery.
around normally, the ants are fine with
Whenever
it.
that
But
giant
just by
guy
a
with
switch in its
magnets
behavior,
comes
the other
nearby.
ants are like, ants should not be laying sideways like the exorcist and flying around. They attack it.
Ant is
So
still
it's not like
biting
a
his
chemical.
head.
Usually when people look at
He
it, it's a
doesn't like the
chemical
way this
change
guy's acting.
that like the
I'm
ant
gonna
has some
release
sort of
the
chemical and they
magnet,
attack
return
it.
to normal.
But this same chemical, just difference in behavior, and they start attacking him. I released the magnet, and they actually let the ant go, which is very strange. But so that's a way of kind of doping your specimen in order to make it easier to
Okay,
interact
it's calming
with it.
down, it's calming down. That ant decided to release it.
And then also, if you test this out at 3 in the morning, you might be
Okay,
ranting a
maybe
lot.
if it's
And then some internet
waking
people
up
might find your video that you put on your blog.
Where am
and
I?
then share it
Oh
with
my
the rest
God,
of the
not
world.
again. That's what it says.
It goes on for a while. I'm gonna leave that. That'll be our ambient work.
You should
for
have
today.
colored them.
Huh?
Should have painted them.
Well, I painted one red. This one right here. That's the one with the magnetic red paint, and the rest are all just regular colored. See, that was the one that I put the magnet underneath, and it was flying around all over the place. She, and I should say she. These are all female ants. They're all foragers. They don't have hormones. So, those are some quick inspirations.
But we would have to need to do more than that, correct? Because we need to somehow.
Yeah. Your project is not just going to be like, look at this. I put a magnet on a cat and I made it stick to the wall. Yes. No, you're going to have to go beyond this. But these are ways that you could use to interact with your subjects. You could take something like make your worms magnetic, and they eat different colored magnetic soils, and then you put them on a painting, and they do 1 minute of crawling on their own, and then based on that you track their movement with magnet sensors, and then you use a magnet and move them around as some sort of reaction or something. Who knows? Yeah.
Could we possibly do kind of a combination of what you said with the laser on the cat, and then maybe how the electric collar starts beeping when you get close to the line? Have the collar on the cat start beeping when they get close to the food?
Sure.
So you can kind of realize what's going on, and then
Yeah.
the laser would be for us and the food dispenser instead of the cat having the food instead of just the beeping. Like the beeping would be for the cat, the laser would be for everything else.
Sure. But I don't even see why you need the laser.
The laser just use the. Yeah. I guess it
You could have little vibration motors on the thing. I'm actually, for my architecture class, I'm designing a vest with different vibration motors on it for a dog, so that you can tell your dog go left, and then you also press left, and it's left side buzzes, and gives it some haptic feedback, so that maybe you can use that to train it. I don't know. Yeah, one more question.
Oh, about eating stuff, could
Yeah.
ants eat something, or worms eat something that's neon, or is that toxic?
Yeah. Look it up. There's so many neon colored food dyes I'm sure you can find some sort of bright neon colored thing that's not terribly toxic. You can always, if you always have a question about the safety of anything, everyone should probably remind this, MSDS. Google like the thing, and then like MSDS. So like you have like, you get a weird piece of acrylic board, and you're like, well, is it toxic? Does it give off fumes? Well, if I put my worms on this acrylic board, will it kill them all? Just look up this specific acrylic board, and then like MSDS. That stands for Material Safety Data Sheet. We talked about this a little bit when we went to the rapid prototyping lab. You'll look on that, and it'll tell you like danger information about it. Like, like this board is non-toxic, but it bursts into flames above 85 degrees Fahrenheit. So, maybe you don't want to use it or something like that. Or, this board is fine with frogs, but kills worms instantly. Probably won't be that specific, but you can find out a lot of the properties about things like that. That's also the kind of plus about using a specimen that doesn't have a spine versus specimens that do have spines, like larger vertebrates, like cats and stuff like that, is that you should never ever be careless with your animals or any of these living creatures, but it's extra bad if you do something bad if you end up accidentally harming a vertebrate versus an invertebrate. Does that make sense? Okay, cool. So I want to give you guys this quick midterm review. First, let's chat about good things that you need to do for your projects. So we talked about this a little bit when you got done with your project 2s. Here's just a couple more things to do. Comments in your code. Don't step on your laptop, Andy. It's about to. So you all end up, you're all getting good at turning in your documentation with, all kinds of pictures and little like reflective essays, all that kind of stuff. When you turn in your code, you should make sure that your code isn't just like blink example created by Leah Beakley or whatever like that. You need to not only just change things around, you need to make it comprehensible for yourself at a later date, and then also for anyone who's looking through your code. So Anna had a pretty good one. I only changed one thing in hers, but she changed her variables. Her variables are not just, I don't think any of you guys have done this, but the most criminal name to name a variable when you're coding is int variable. That is just so pointless. You can give it a name that means something. So relay, oh, it's where the relay is going to be attached to. I get that. It's not just int variable 1. Int mic, oh, that's where the mic's going to be attached to, I would assume. So this makes things a lot more clear. She even then gives comments about like, okay, this variable is going to be the noise level. Even though that may be obvious with the way that the variable's named, it's just the more comments, the better. It'll be better for you because you'll eventually come back to this code 10 years from now after the apocalypse, and we all need to make crickets chirp on command because that's the only way we can have energy in the world. It's the apocalypse. It's weird. But you're going to be looking back at your code and be like, what does this do? I forget. But if you comment it, it works really good for you. And it helps everyone else out, helps me out. Very important. One more thing to do, especially when you're doing your final project and you're turning it in, just give a little description of what the entire sketch does. Again, for you, for me, for the rest of the world. So like, okay, project 2, cricket chirp. This sketch detects a certain noise level from the crickets and then triggers a relay to turn on a bright heat lamp or something like that, okay? So everybody got that? Comments in your code. Cool. Another thing to do, in progress documentation. I think you guys are pretty good with this, but it's really important, even at these very early stages. Like, when you guys just have a box of worms. Like, they sent me a couple pictures yesterday of them like buying worms. Perfect, really good documentation. You want to document your entire process because you're going to be making changes and you're not going to know what's important until you're actually done. So you may be like spending an hour raking this lawn to find weird grass bugs or something, but you didn't even realize that it was because you were raking that, you know, it led to your new rake bug alligator controlled lawnmower. I don't know.
Yeah.
So like, and when Eric was doing his middle documentation where he just tested, he put like his wallet and his phone or something in the car and it just rode off crazy. That was really good to show that he was thinking not just about like, I'm going to put crickets in a thing and make the thing go. You know, he was thinking about the cricket safety. He tested it with non-crickets before the thing went nuts and, you know, drove off down the road. So that's really good. That's the kind of documentation you want. You want to just, you want to basically set a little alarm in the back of your head whenever you're doing projects for this class, even if it's, you know, you're just walking through the woods, you're doing something, whip out your phone, take a picture like every 5-10 minutes or so. Okay? Make sense? Here's another really good thing that some people did was you're going to have to demo whatever you do. You're also going to have a fully implemented device that does what you say it's going to do. Your demo and the actual thing may not always be the exact same thing. Because you guys know the demo demon? Who knows the demo demon? You've never been
What?
Janet Murray's classes? Janet Murray says, and this has been proven millions of times, there is basically an evil demon that comes and visits all demos. And right when you are setting up your demo, 20 minutes, 5 minutes right before your people walk up to see your demo, something in it magically breaks. So we saw this a little bit. I believe Emily Russell was a bit of a demo demon, right? She wouldn't stop on your thing. And so the demo demon's going to come and visit. He's going to destroy all of your projects. He's going to kill your animals. He's going to blow up your computers. This demo demon is mean. So what's good is to have not only your final finished code, but also sets of other code for demonstrating maybe just some of the parts. So like if you have a piece of code that it just makes your flowers move up and down and go into all the different slots, that's good to show us that you can control this. This helps because not only does the demo demon visit and break everything, you still want to be able to show that you still did all these individual pieces. Sometimes your project operates at a different time span that is not amenable to the human attention span. Or like class time. So if, like Danielle had a thing where it would hurry up and quickly lift and like move the flower around, but her actual thing would keep the flower in for a much longer time. So it's good to be able to have code that demonstrates as well as the code that actually functions. Make sense? That's awesome. Okay, everybody, get a piece of paper. Oh man. Oh, look at this. This class is full of paper. We all have these. You don't even have to rip them out of your beautiful, precious journals. Who is falling in love with their journal so far? Good.
I love my
Okay, good. Cool. Yeah, it's a good buddy. I had a scare yesterday. I left my journal at a restaurant. And then I had to go running back, and the waiter was just like, I have it, and then we embraced. It was very nice.
That's great.
Okay, so what time is it? Who knows? 12:20. Oh man, we got all kinds of cool stuff lined up for you guys. So I'm gonna ask you guys questions. you're going to write down your answers to these questions. Oh man, this isn't just play. Andy, I thought this class was run around with animals and make things blow up. Haha, you actually have to write stuff too. It's crazy. So, questions for you. I'm going to give you maybe a minute or something. This one I'm going to give you 5 minutes. Write like a sentence for each of these things. What are the goals of this class? What do you guys think the goals of this class are? What's that?
I'm sorry, do you want us to write down the questions so you know what our answer refers to?
Sure. Or you just write, number one.
So is it like our goal for the animals, our goal for the humans?
This one is, what is the goals of the class?
Of this class?
Yeah, so you're taking a class. I've yammered about lots of things. What do you guys internalize?
To write 3 different things for that?
Yeah, for this one I want you to write 3 different things. What are our goals in this class for the animals? What are some of our goals in this class for the humans? Humans in the class, humans in the regular world. What are our goals for like digital media in general? So yeah, do like a sentence or 2 for each one of those, and maybe just a couple minutes. Hey guys, 20 seconds.
No.
Sorry.
I have an answer for that.
4, 3, 2, 1. Boom. Okay. Really quick. Oh, the Ishii paper. The Ishii paper. Yes, I warned you many times. So, in his very first paper about tangible bits, the oldest one from 1990, maybe it's now 7, I think. 7, 8, somewhere around there. He discusses 3 kinds of levels of interaction. Levels of interaction is like 3 different things that he talks about. Yeah.
I can't remember the exact names.
Describe it. Describe it as best as you can. This one's really quick. Just describe as best as you can. Whatever. You have 20 seconds. Seven, 6, 5, 4, 3, 2, 1. Okay. How do you think the Ishii readings pertain to this class? Is it completely irrelevant? What physical, computing, tangible bits? We hate that. We hate the real world in this class, right? I don't know. What do you guys think? So how do you think the readings pertain to this class? 20 seconds again. These are gonna go. These are quick. These are gonna be rapid. Is it what? Aren't all questions opinion questions?
That was actually fun. For one.
Oh. Pop quiz burn. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. You notice we have some time inflation in this class. 20 seconds lasts for a while. How did the Ishii readings change over time? I assigned you 2 main readings. The first one, tangible bits. The very lastest one, there's one in the middle too, but as I directed, just kind of skimmed that one. The very lastest one, radical atoms. What are his main differences between these 2 things? Did he write the exact same thing verbatim? Was it the same pictures and text in both readings? If so, you may have just opened the same PDF twice. Five, 4, 3, 2, 1. Next question. What kind of students are you?
I was going to answer that.
let me know what kind of, what are you looking at? What are you officially? What are you unofficially? What are your desires? All written down in 20 seconds.
What if
We can do the
At
breakfast
the-
club thing. Everybody can win.
Joe. I'm an introvert. Oh, good, I never cared about it.
what if every midterm ended with this question, or like every exam?
It should. Yeah, once I have my way, and all academia under the influence of major quickfire, then that's what will happen. But you may be safe once you take the class. I don't know if it's the last question either. Oh yeah. This was actually multiple choice, but I don't even show you what the choices are. So you better hope you get A, B, C, or D correct. I don't know.
E for all of the above.
D's all the above. F is, I'm not sure if
None of
there's
the
an
above.
F.
None of the above.
F is you should have chosen.
Where's Mary?
Mary emailed me and said that her car broke. Oh, and that she.
Mary has troubles.
Don't we all?
You know, Mary's popular. That's a big trouble.
And computer broke.
And so did Mary.
How's your computer doing?
Y'all are normally so quiet and don't say funny things. Me on a normal basis, anywhere else.
Okay, I think that was the last question, actually. Okay, cool. Let's start with the questions real quick. Everyone, pull up. Round table. Hop up here. Oh man, I've never written like this in my entire life.
What?
It's just like so organized. It's beautiful.
Don't look at mine.
Everything's so clear.
Get over
Oh,
that.
Oh, that's still pretty great too. And there's I like human students. Interesting.
Wait.
Oh no, I'm totally.
Hold up. We're just going to discuss questions. So, what do you guys think that? What were some of your goals for the animals in this class? What do you guys think? Turn your chair around. Pull in. Here. There you go. There you go.
I said to like control their behavior and their environment in hopes of like improving it
Okay.
and teaching them something important. I said something similar. I said to observe animals so that we may perhaps manipulate their behavior and actions in a way that's favorable to us in our project.
Okay.
I should be
So yours
opposite.
is a bit more human-centric. That's okay. I'm going to let you guys know real quick. Most of the questions, there's no wrong answers. There's a couple ones where you can have wrong answers.
Yeah.
But most of them we're going to say no. Yeah.
I said the opposite. I said to let the animals continue doing their thing and perhaps smartly interact and like let the animals smartly interact with the computer too, and to bring down the button. That's just a joke.
Yeah. Buttons are evil, right? There's too many buttons. Buttons. There's probably two things that I can guarantee you're probably going a wrong direction. And with your project, you can just use these as like guidelines. If your final project has like a button that a human needs to like touch, or very like a keyboard button or something like that, probably going a wrong way. Your animals need to interact. We don't care what the human. I mean, maybe if that's part of your project, but you probably want them to interact with the animal more in other more physically amenable ways. The other thing would be video displays. If your project's outputting on pixels, unless you're doing something like, there's one project that these cat interaction guys have that uses a video display. But unless it's very meaningful for the animal, chances are your video display is leading you kind of in a wrong direction. Very good for like debugging for human purposes, looking at what the variables are doing. Not very good for your worms who really don't care what your monitor is doing. Okay? So I would say, as the teacher, that one of my goals for the class is kind of in between your goals. It's to basically create a connection between the computers and the human people to more so relate to the animals and let the animals have influence in our digital world and physical world. So yeah, what other people put for the humans? That was the second part, right?
I put our goal is to explore the use of computers, Arduinos, and human and animal interactions. We want to study how we as students can come alongside of these animals and interact with them and mimic their behaviors in a safe way to learn more about how they work.
Cool. Yeah. Any other people? Yeah, Larry.
Become capable of building devices through building devices.
Yeah, exactly. Yeah, so that's another great goal. The animal aspect of this class is like a really good challenge for you that forces you to kind of like go outside of traditional design and building things and forces you to make things in the real world that have to meet a job that you can't, just like, there's a lot of studies that you'll see, human-computer interaction studies, where the person can be kind of like, I don't get what I'm supposed to do on this screen, and you're like, okay, well, click that button. You can't always do that kind of thing with like your worms. You can't be like, come on, worms, you're actually supposed to go over there. So you actually have to become very capable at building these things yourself, and the animals is a good way to lure you into it. Great point, Larry. And finally, for just like the computery side part, the digital computational media stuff.
I said apply digital media to everyday life and environments to give it a tangible purpose. Using biotic agents will help transform digital media into something much more interactive.
Ah, you guys are awesome. I must be an amazing teacher. Or I guess you guys could just be really good students. Yeah, spot on. Super cool. Other responses people have.
I said that digital media is almost used as our second brain in this class because it allows us to interact with things.
It's and I would say, I want it to be more than your second brain. I want it to be secondary. I want it to be secondary appendages, to let you guys have not only two arms that can type on keyboards, but an extra arm that grows out of you from these digital appendages you make that lets you interact with worms and stuff like that. Cool. Awesome. Okay, should we jump into questions with more of a right and a wrong answer? The next one, the pop fly question. The Ishii text, right? That's the next question, right?
I don't think I got that wrong.
Okay. who thinks that they got it? Who thinks that they got it wrong? Raise your hand. Okay. Larry, just tell me a wrong answer.
It was not digital, kind of digital, all digital.
No. One more wrong answer, then we'll jump to the people with the right answer.
Hamburger.
Hamburger.
Three.
Really close. You had another wrong one?
Yeah, I put GUI and then TUI and then HCI.
In the final paper, he discusses GUI, graphical user interfaces, TUI, you guys know TUI?
Yeah, tangible.
Tangible user interfaces. And then at the end, he also suggests one more.
I don't remember what that was called.
MUI. It was MUI, MUI, material user interfaces. Anyway, who thinks that they got that question right? Pop fly.
I couldn't remember exactly what was going on, like with the terms.
Sure.
But I said like the GUI, which would be just like a purely digital on the computer agent, and then there was I said digital and tangible, and then I gave an example for like instance, Legos. One of the examples is like Legos are some kind of building blocks that can remember how they're placed, and you can, I guess they could like rebuild themselves. So that was an intelligent, tangible item. And then there was something that was, like, I guess, the third one, which I guess is what their goal is. I couldn't exactly think of a way to describe it, but I said it was like a completely tangible and immersive, like, digital agent, like the material itself was intelligent,
Yeah.
which is what I thought they were going.
So I think what you're talking about, what I think a lot of you guys were talking about, minus hamburger, was the last paper about radical atoms, where he discusses the kind of 3 levels of bringing the digital world into the physical world. The first thing that I wanted to talk about was the very first paper, where he discussed 3 levels of interaction for all of you to think about. In bringing tangible user interface. So the first paper was all about tangible user interfaces. And he references this guy, Mark Weiser, all the time, who was the first guy to kind of coin this term, ubiquitous computing. And they talked about different ways of interacting with computers. One was the meta desk. So he had 3 examples. One was meta desk. It was like this desk interface where you would interact with little like tabley things. One thing was, I think, called the trans board, and it was about like a board-like thing where you could manipulate things or it could act like a window into different areas. And the final one was the ambient room. I was trying to give you hints during the thing. I was slapping desks and hitting boards and
Did you notice
motion.
any of that? I'm sorry.
Spatial, visual, and tactile.
It's more about, I think, different levels of interaction is what they were thinking about. So like small interactions, small maybe personal interactions, more kind of shared cooperative interactions, and then much larger ambient interactions with larger spaces. And so that's something to think about with all your projects, how you're interacting with the space and what size of space. Are you having a very tiny Pac-Man worm game? It's like a Game Boy, pops in your pocket, full of worms. Or is it going to be these little worm tubes that go all the way across an entire room or an entire field outside? Who knows? But it's something to consider. Okay, what's the next question?
The reading, if you think they're relatable to.
Oh yeah, it took class.
Yeah, how did people relate the readings to the class?
So it's very relevant to this class because they want to interact with the environment. So the readings teach or explain how to interact with the environment at different levels of the environment.
Other people?
Pretty much the same thing. It's made in the environment to interact with the environment. Since our thing is pretty much changing the environment and we just happen to throw in animals as well, it would be useful since that's pretty much what we do.
Yeah. Well, yeah, I mean, so in talking about like mimicry and stuff, so everybody reread, this is going to be the very last mentioning I even mention about the Project 3 assignment. It's a big, thick document I sent out you. I've told you guys to read it 3 times already. There's a part where I talk about how your project should be like that giant stick bug. Have you guys been to the main class website? There's a great picture of...
On your face?
Exactly, yeah.
Yeah.
It's huge. Those things are giant. So these things, you could think of them as little tangible user interfaces that were created, over millions of years of all these different influences, and they're dynamic, and they probe and investigate the world. And the world has shaped them. This thing kind of looks like certain parts of the world very overtly, but it also influences itself back onto the world through these kind of different affordances. It will move still whenever there's other creatures around to act like a stick better. But it'll also run up and use its sharp mandibles to like tear up bits of leaves or whatever it eats in order to interact back in the world when there's other non-scary things around. So your eventual device needs to take cues and affordances from the environment and what your animal can do and what your animal, how it reacts to things, and then also respond in its own ways back into this world, contribute to this environment that's always changing in flux. Cool. For time's sake, let's keep on to the next question. What was the next one?
Is there a change?
Change over time.
Change over time. Oh yeah, how did the 3 readings change over time? So there was like 10 years apart when you wrote these.
The first reading was much more like scientific and fact-oriented versus the second paper, which was the radical, what was it called?
Radical atoms.
Radical atoms. That one was much more like, it included all the scientific stuff from the first paper and just, facts and examples, but it was a lot more about the possibilities for the future and the point of it all. But they were both papers were on the transformation of computing in terms of interaction.
And yeah, so on that point, there are 2 different types of papers.
Yeah.
One is just like, like a journal article for like, ACM, computing machines and stuff, where they're going to be a lot more fact-based. The other one's like, oh, okay, we have this dude who's big and famous now in this field. Let's give him kind of like, almost like a pop science, like glossy, nice spread that kind of works as like, I think there's like, the keynote kind of paper within this, compendium of other papers. So it's going to be like that, where it's a bit more like visionary. But he also mentions the way his research is shaped, right? It's vision-based research. He has this part at the end where he talks about how his research is vision-based because most technologies go out of date within a year or 2. But if you have these big, crazy visions of the world, those visions can keep consistent and evolve even past your own lifespan. So his idea, he wants I want every one of you to tell me a project, or even if you don't know its name, describe what it was from the radical atoms paper. Do you remember one?
Not off the top of my head, no, I don't.
Okay.
Wasn't it like putty stuff?
Yeah. You remember what color it was?
Red?
Yeah.
Perfect red?
Perfect red. You got it. Nice. Yeah. There's like this weird putty stuff that you make semantic gestures onto, and then it would automatically like sculpt and mold itself. Another project.
The one that I mentioned in here that I really liked was it Legos?
It was colorful block things.
Yeah,
and you mold them into a dog and you move the dogs.
Like a worm.
It had a weird name. Yeah.
But I thought that was really cool that I could like remember how it was placed. Almost like muscle memory or something like that. It's just
Oh.
intelligent, which I if I were a kid and I had that, I'd be like.
Okay. Any more? Before it? Nope. Nope.
Well, with the MetaDesk, it kind of reminded me of that game with the ships where you
Battleship?
Yeah, battleships. That's what I thought of. It's like an interactive flat surface with it's just location based, right?
Uh-huh.
So sort of.
Yeah. Yeah. Go back and at least look through the radical atoms paper again. They have big, cool pictures of amazing, crazy stuff like levitating interfaces.
Speaking of things,
Yeah.
I saw something I would like, and they have these blocks, and they're little robots, and they have little pistons inside, and they're capable of moving themselves.
Oh,
and
yeah.
They have magnets, so they build themselves.
Oh yeah, those self-assembling things. That's a good point that you bring that up. That is going to be, you have 3 homeworks for Tuesday-ish. One of them was find an interesting resource or article that you want to share with the class that's related to our kind of cybiotic interactions or something like that. So, and you would basically just get a picture of it, write a sentence about it, and then post a link on the class website. Okay, make sense? So find interesting cybiotic, and look for maybe that thing's a little bit more removed
from, it's not directed with animals. Try to see if you guys can find an actual like animal-computer interaction thing yourself, and just post that to the website. So like, pick, sentence, picture, sentence, and link. Super easy. Just browse around for something cool. Another homework is we're going to have you read Orphle. I sent this text out to you at the beginning of class. And then your only other homework is you're going to get a scientist, buddy. Scientist, buddy. So, you guys are taking a class. You're taking a class in a field that does not exist. That means you got to end up doing a lot of things for yourself in this life. So one of those things is going to be you're going to have to talk with a scientist. Talk for at least 20 minutes between now and Thursday. You have a week, okay? This scientist needs to work with animals, or plants, or fungus, something living. Don't go talk to a math professor, scientist. Now, I'm not saying they don't have anything to offer us, but right now, the assignment is we're looking for a living creature. Biologists, they call them. There's also things like molecular biologists and people who do stuff that use like chemicals that come from life. Those probably won't be as fruitful as somebody who has a giant tank of lobsters that interacts and does experiments with these every day. So you're gonna find one of these people. I'll send you a link that lists all of the faculty in the biology department in like evolution and ecology. You can email these professors straight up. They're super nice. I emailed Jeanette Yen, who runs a lot of biology stuff, yesterday, and she's probably going to let us go for a little field trip during either Tuesday or Thursday's class next week to go see some of their weird lizards and tanks and stuff like that. But you're going to go up to them and just kind of chat with them, maybe 10 minutes about whatever they do, 10 minutes about what your project is, and if they have any cool ideas for how you can interact or keep your thing alive. That's going to be an important kind of thing. Keeping his worms alive is going to be, he has to keep them moist, he has to keep them fed. It's not a very hard science, but there's a science to it. The person needs to be at least a grad student. So somebody working for their master's or up to a full tenured professor. So you can ask the professor like, hey, I'm in this class, my professor's such a jerk and he makes me do all this stuff, but I need to chat with a scientist sometime between now and next Thursday. Can I chat with you, or do you have any good grad students that I can chat with that would be good to talk about these kind of things? Sound good? Everyone got it?
Can we talk to a doctor?
Can you what?
Talk to a doctor, or is that not considered a scientist?
You mean like a medical doctor? Because lots of these professors are going to be doctors.
Yeah, I mean.
Yeah, medical doctor. I'm gonna say no. I'm gonna say veterinarian, yes, but not human doctor. Cool. Okay. I believe we have one more question, right?
What kind of...
Yeah. What kind of students are you guys? What are you, Larry?
I'm a Cybiotic student, but I'm more Cybiotic because I like the Cy more than biology.
Okay. Well, do you know what the psi means?
As in cyborg?
Yeah. What does it mean in cyborg?
Robotic technological.
A little bit. Wow, this is a good question, guys. So, the reason I came up with this term cybiotic is because it's got the biotic part, right? Animals, a living entity. Then it also, I will. It has and then it has the biotic, right? Biotic, some sort of living thing. The side part, what is the side part? Comes from like cyborg, right? What's cyborg?
Robot.
Kind of like a robot, right? Some sort of, so a cyborg is a cybernetic organism. That's where cyborg comes from, right? So you guys know what organisms are. So why isn't this just cyborg interaction? Well, the biotic is to get you out of just, usually the cyborg we think of humans, half human, half robots. The cybernetic part, that means something actually a little bit different than just like robots or like machines. But it still has a good connotation. So we have one part we think of as, like machines, computers, right? But it's actually a little bit more than that. What this comes from is a Greek word that's like kairos or something. I'm not totally sure what this is, but it's something like kyber. And in Greek, like a C's or like a K, or like Cyclops. It's actually Cyclops, not Cyclops. But anyway, what this is on a boat. I said boat, strange. You have this little thing. On an old Greek boat, you have this little kyber or something. And it's basically the steering mechanism. And so the reason this came into cybernetics is because cybernetics is not just about machines or like digital stuff. It's about controlling and control systems and making systems that are responsive. And the way that you have a responsive system is you take an input and then you also do something with it and you push out and output. Yes, exactly. So that's where I made this little term up from. It comes from control systems with living things that also has this great connotation of machines and computers. And the reason we have machines and computers is because they're kind of these really amazing, adaptive, fast things that let us control and manipulate things very well. Cool. What kind of student are you?
I said, technically, officially, I'm studying computational media, but in this class it's more like a biologist because it's studying nature and interact with it. And I said it's an interactive class and fairly rewarding. I didn't really think to say I'm a Cybiotic student, but I said biologist.
Yeah.
I feel like I was fairly close.
Cool. Alex?
I didn't really go into that, but I said I really just cause of this sometimes I feel overwhelmed because I'm the amateur of all amateurs, however I tremendously enjoy what I've learned so far.
Good. I wouldn't be so hard on yourself. Doing great. And you all have your own unique backgrounds. That you've all gone out and seen spiders and played with them, or ran away from them very fast. Cool. Eric.
I like hardware interactions and I enjoy
Cool.
I would define myself as learning new things about animals and learning how to not cringe as much about insects.
Danielle?
I said I was human.
Human.
Hamburger.
human hamburgers.
Cool.
I
wanna be
And then one of the only things that I wanted you guys to also think about this was that on top of all this, you're also computational media students, most of you.
Stat.
Stat, who else is not? Everyone else is CM, right?
Well, you're an honorary computational media student.
Yeah, well, I'm learning about it, which
exactly.
is welcome.
And so one of the differences in this class is that you're not going to be here to simply make a device that just tries to prove something or prove that the device is running. You are media students, so your thing needs to be somewhat expressive. So think about with your projects always about how you can make your project tell a story, how it can play a game with yourself. Different ways that you can map these higher level attributes of human life and expression onto these strange mechanisms that you've been making. Okay? So like remember, think back to like the tortoise loves me example. Most of your ideas were just like, okay, I have a thing that beeps when the head goes in and out. When you give your final presentation, you're not going to be like, look, I have this thing and I have a worm and it beeps when the worm folds in half and doesn't beep when the worm doesn't fold in half. Boom, there it is. That kind of job is for like computer science people to just be like, look at this, I got a computer doing stuff. You guys you have much more responsibility than that. So you need to be like, look at this amazing worm system. It is folding in half, and it represents the tragedy of the Great Depression because these worms invested in their material. Who knows? So you need to map it, this mapping exercise, to larger things. So media, your students, map it. And Larry, since you're Mary's partner,
Yes.
Can I charge you with sharing all of the great stuff that we've chatted with today with Mary? Perfect, thanks. One last thing. Cat interaction examples, even though you may or may not be working with cats. There were two great PhD students who had the best demo I've ever. Have you guys ever been to Digital Media Demo Day? Or GVU Demo Day? GVU Demo Day is coming up, not next week, but the week after. You should all go to it. I think it's like Wednesday over in TSRB.
I went when you presented the peeing thing. It was great.
Oh, really?
Yeah.
Nice. Cool. Wow, that's good. That's probably 2 years ago now.
I worked for Brian at that time.
Okay, cool.
Yeah.
So she saw me give the demo of peeing on stuff and weirding out all the real estate investors who come.
It was great.
It was great. But the absolute best demo that's ever happened was by these guys, Brian Shrike and Jeff Thomas, in 2009, I think. They got lab coats, and they set themselves up as this like false personas of. I'm gonna skip.
Oh, that's beautiful.
They set themselves up with these false personas as these guys from this company called Zoocentrics that just happened to rent out a little room during the demo day. And like there's all these like business people, and they just kept a straight face the entire time. We're just like pitching them like all these ideas. They pitched them basically a suite of different ideas. They had business cards and all kinds of stuff. What is slideshow hell?
That Sun Secret thing was pretty great.
And so they presented lots of different projects. And I want you to pay attention not only to projects, but look at all the other work that they put around them, all the media artifacts that they put around them to kind of seal in these strange concepts that they had. So lots of concepts are very simple, but the way that you frame it is where it gets its power. So they had a motion-activated meat mobile for playing with your cats. It'd be all these dead fish and dried jellyfish hanging from this mobile inside this place in the demo day thing. There were these cute stuffed mice that they would kind of twitch their little tails, and the cats would like run up and paw to them. Then there was custom cat TV. So this is the only thing where they use a pixel-based interface. They have different things video that I think cats might be interested in. And when they have a little motion detector, like you guys used, and whenever the cat got closer to it, this
the screen would be constantly showing different images, but then it would slowly show just one video. And so when the cat got closer and closer, then it would just like freeze on like one video loop, keep going and going, because that's what the cat chose to watch. So it was like kind of remote control for a cat. Sunseeker, there's this little robot, there's like a robot cat bed that drove around places and found the place with the most light. So the cat knew like, oh, I can just sit here, and when the sun moves across the sky, I'll always stay nice and toasty and warm. And I won't have to keep moving, which is great, right? Then there was this, then they also had a project called Mama Belly Bed. It was basically a nice cat bed full of nipples and milk. And so the cat can kind of like cuddle up there and just like drink milk from all these nipples that they had everywhere. I emailed them yesterday and they said it's still in use today. Good old Mama Belly Bed. It's got a great name too. These were just some little sensors that detected, this was not Mama Belly Bed. These were some sensors that also helped detect when the cat approached the TV. They had, this thing was called, I think something like Feed Me or something like that. Basically, it was a feeding device. People were worried about if their cat got lonely. You could call up your cell phone attached to this thing, and it would move a little mouth flap with how you talked, and then it would also spit little food pellets out for the cats while you were talking. So it gave you this like physical reinforcement of this flapping, gustatorial reinforcement from actual food, and then also audio, so the cat could still bond with you a little bit while you were gone. And so then they also, then they lead all this up to like, well, see, the real thing about pets is that they should not just be this extra thing, they should be really an extension of yourself. And so we're working on developing this tiny puppy that it's super small, genetically engineered, super small, lives on your wrist, and you don't have to worry about feeding it because it bites into your own arm, into your bloodstream, drinks your blood, but then it just defecates right back into your bloodstream too, so that your own kidneys just filter it out. So you don't have to worry about cleaning it up in the park and stuff like that, and you're never lonely.
It works on paper.
and so it not only worked on paper, they were like, so we have a demo of this. They have little AR fiducials you'd like strap to your wrist, and they have all this branding stuff about it. And so they have this rhetoric that's behind this entire elaborate project that was all about the weird ways, kind of like a critical look at weird ways that people interact with pets and living creatures, and how this can be extended in very far, strange, sci-fi kind of directions. And so, this thing wasn't an actual animal or anything at all, but because of the way that they presented all the works leading up to it, and all this media and branding surrounding it, it kind of really capped off the piece. So it added this kind of speculative fiction aspect to this overall work. So this would be a really good example of kind of an elaborate piece that could work in this class, even though not every aspect is just about the actual animal-computer interaction. They all work together to kind of promote this. That's cool. Finally, real quick, let's talk about, probably not going to do a field trip this week, because the week's over. Maybe next week, people were talking about being interested in a field trip to PetSmart or something like that. And we can look at all the weird animal interaction devices they have there. Just quick show of hands, who would be interested in a field trip to PetSmart? Cool.
Sorry,
It's okay, it's okay. You don't have to be interested in everything. Danielle came out to one of our little optional things and got to see some human-apple interaction. Yeah, we ground up a ton of apples.
great.
It was awesome.
Can I show off my bag that I got? I'll wait.
Sure. Oh, yeah, wait till the end, just because I'm always running behind. Other thing, field trip, not this Friday, not next Friday,
but the Friday after that, November 1st. What is it?
Camping.
Camping! I'm going to send out an email to that huge list of all sorts of people who will be coming out that I've been emailing updates and reminders to the camping about. But I personally am going to go up Friday, early afternoon, probably around like 3 p.m. or something like that. And I'm going to have my car and all my camping equipment. And I'm going to go up there then with my wife, and I'll probably have room for 2 or 3 more people. If anyone's interested, I'll give you guys first dibs on spots in my cars before other people, because you guys are my class. You guys are awesome. So if you're interested in any of those spots, email me if you want to hitch a ride with me. I'll be probably the first one into the campsite, probably the last one out. I'll be coming back Sunday, probably like noon or something like that. But we have the place for the entire weekend, and if you come up on your own, that's fine. You can come up later Friday night. You can come up just for Saturday night or something like that. Saturday during the day is where we'll probably have the most activities. Just hanging around, building fires Saturday night, hunting down more ants and stuff during the day, doing all kinds of fun little activities or whatever we think of. So if you're interested in that, let me know, and I'll send out another trying to get cars and stuff arranged email tomorrow. And then we'll figure out PetSmart trip maybe next week or the week after that, something like that. Finally, what do you guys want more of in this class?
Can we say what we want less of?
Sure, what do you want less of?
Reading.
Readings, really? Not been digging the reading?
You know what I love? I love when you stand up there and talk about something more than you say, read this.
Uh-huh.
Because it's, and maybe that's just lazy on our part, or just my part.
It's a little
I may
bit,
say for
a little bit
myself.
both.
But it's engaging when you are talking about it, and I find it easy to pay attention to, because you're so enthusiastic about what you're talking about. Whereas when there's this paper in front of me about atoms, I'm like, oh my gosh, why? So, yeah.
Are we gonna do the things with the ants that you guys put?
We didn't end up getting that many ants.
But Danielle got one.
Oh, we had a
What
bunch of those.
happened?
Yeah, we had a bunch of those secret weird ants. I went and let those out after class because they were escaping all over the place.
The small ones, you
Yeah,
did?
the little small ones. I let them out.
Where's the big ones?
Big ones are still back there. I don't know if they're still going.
It's
But
been a while. It's kind of cold in this room.
That's another point. PetSmart has these little heaters that you usually put in our ants in our ant lab. We have them underneath these heaters to kind of keep them at a regular temperature. You might want that for your different worms. If they normally live in an air conditioner, but worms are pretty resilient.
Could you
Could we go to the
grab
ant lab?
Yeah. So next week I'm planning on trying to get you guys a field trip over the biology places, but I also might bring you to my old ant lab too, and kind of show you how those ants work. You can touch them, play with them, put them all over your face.
I don't think so.
Okay. Any other things? Things you want more of? We discussed readings.
More videos.
More videos.
Yeah,
I think the videos are kind of cool.
Videos are
Like
pretty
just
cool.
random little. I found this cool stuff.
Uh-huh.
Yeah.
Cool. And if you guys find cool videos too, like you're supposed to do this weekend.
Find a video. Can it be a video or an article, or you want an article?
It could be video, anything. Yeah, just something, just share, if it's not, you can embed a little YouTube clip or something if you want for the picture. Any other things? Alright, so about the readings. So yes, it is more fun to have a big, enthusiastic guy break down a lot of stuff for you. But it's a trial by fire. A lot of these readings come from all different sorts of things. And in order for my talks to be as effective as they can, you guys also need to be kind of priming your own brains with stuff that's going to be hard. It's going to be really hard because, you're not very familiar with this weird context. They're using a lot of weird lingo and stuff like that. But so don't be worried when you have the reading that I'm having a hard time getting through this. Because that's why we then have the class. The class is supposed to be, so termites have, such a bio nerd. Termites have these like special mutualism, these bacteria that live in their belly that digest the wood for them. The termites can't just eat the wood and just turn it into energy and stuff like that. They have to swallow it, and it has to be digested in their belly by these extra things, and then they eat basically what those things poop out. So, you guys, the readings are going to be your big termite mandibles. You're ripping off these huge chunks of wood. It's scratching you up on your insides. It can be very difficult at times. But then, when we get to class, then Mr. Andy, the big bacteria who lives in your stomach, they'll help you chew and break down this stuff so that it can be more palatable, and then you have a lot more knowledge about this. And the reason I can't, it's good for you to learn this way, because otherwise it's kind of just spoon feeding you, and you're not bringing your own ideas and concepts or questions or difficulties to the class. It's just me telling you this is the way things are. And so I realize there's a lot of reading. You guys do way more work in this class than so many graduate level classes that I've seen. But it's going to be a difficult class. It's going to be a difficult class in many different ways. But it's going to be a really cool class. And as you may have seen, you're going to do strange shit. And you'll be able to talk about this with future employers or other people, and I think they'll be happy. With that being said, you don't have that many. I've tried to front load a lot of the readings to give you, yes, I would like to collect all of your papers. So I tried to front load all of the readings so that you don't have that many readings to go. This last reading is probably the longest reading that you'll be doing for the rest of the semester, this final Warfel reading. And this one is pretty pragmatic. It's all about how to prototype stuff. And just like what prototyping helps you do. So it should be helpful, get you to think about like what's the value of actually making stuff versus just being like, it'd be great if this laser cat existed, but not actually doing anything, and the ways that you can learn from reading. So that being said, I hear you, I totally understand. Reading sucks, but you're almost already through a lot of it, and it's good for you. And you'll be super readers in the future. Okay?
I brought these back. I'm going to put them back.
Question,
Heard.
I want to do a PTA.
I owe you sensors.
Okay, cool.
The professional practice.
For sure.
We have no idea.
No.
We had it on
All right, email me if you got any questions. Have a great weekend. Yeah, good luck finding scientist buddies.
Bye.